This is an A-level Corpio question on an area enclosed by a polar curve. Figure 1 shows the design for a tabletop in the shape of a rectangle ABCD. The length of the table AB is 1.2 meters. The area inside the closed curve, so that's this white area here, is made of glass, and the surrounding area, that's the shaded area around here, is shaded in figure 1, and that's made of wood. So this is the wooden part here, the grey part, and this part in here is the glass part of the table. The perimeter of the glass is modelled by the curve with polar equation R is equal to 0.4 plus A cos 2 theta, where theta is between 0 and 2 pi, and where A is a constant. Part A, show that A is equal to 0.2. Now it would make sense that the pole is at the very center here, and this being the initial line going over here like this, and we know that the distance from the center there to the edge of this is going to be 0.6 meters, because that's just half of 1.2 meters. So this distance here from the pole to the very edge of the glass part of the table needs to be 0.6, and we need to get that 0.6 when theta is 0, because this initial line here is when theta is 0. So we've got theta equal to 0, and when theta equals 0, what we want is r, the distance from the pole, to be equal to 0.6. So we can substitute those values in and use that to work out the value of A. So 0.6 is equal to 0.4 plus A cos 2 times by 0, because that's an angle of 0. So we'll take away 0.4 from both sides. So we'll get 0.2 is equal to A times by cos of 0. Now the cos of 0 is 1. So that means that A must be equal to 0.2. Hence, given that AD equals 60 centimeters, part B, find the area of the wooden part of the tabletop, given your answer in meters squared to 3 significant figures. So AD is 60 centimeters, that's length here. I want to give my answer to meters squared, and this is given in meters. So I want to give the length AD also in meters. So we'll write that down as 0.6 meters, which is going to be this measurement here. Now, if I want to find the area of the wooden part of the tabletop, that's the shaded area, what I need to do is to find the area of the rectangle and subtract from that the area of this, the shape that's inside. So we've got a shape that's like that. So we'll start by working out the area of the rectangle. That's going to be the easy bit. So area of, and I guess the area of the rectangle is the area of the complete table, of the whole table, so area of tabletop, and that's going to just be 1.2 times by 0.6, and that will be 0.72 meters squared. Okay, so that's going to be the area of this part here. So let's just put like a little bubble around it or something so we don't lose that answer. And now we'll do the bit which is, I guess, the tricky bit, which is going to be to work out the area inside of this polar curve here. Now, as I said before, the pole is here at the center. My initial line is going to be over here like this. And because this shape is symmetrical, there are different ways I can do this. I could use limits from 0 all the way to 2 pi and find a complete area, or I could use a limit of 0 to pi over here. That'll give me half the area and then double my answer. Or I can use a limit from 0 to pi over 2, and that will give me this area, this quarter area here, and then times that by 4. So I could do any one of those methods to find the area of this part here. Now what I'm going to do, I'm going to use limits of 0 and 2 pi, because that way I know whatever I get is the answer. In an exam, if you use limits of 0 to pi, for example, you may forget to double your answer, it's easily done. Or if you use limits of 0 to pi over 2, you may forget to times your answer over 4. I know that if I use limits of 0 to 2 pi, I don't need to worry about remembering to multiply my answer up. So just a reminder of the formula to find the area enclosed by a polar curve, and that's half the integral between my limits of alpha and beta. In my case, it's going to be 0 and 2 pi, and then r squared integrated with respect to theta d theta. So I'm now going to be working out the area of glass part of the tabletop, the area of the glass. So a half, and then limits of 0 to 2 pi, and then it's going to be r squared, so it means to be this squared. Now remember from part A we showed that A was 0.2, so it's going to be 0.4 plus 0.2 cos 2 theta all squared d theta. So let's start by actually squaring that all out, because the inside's not linear, so I can't use the reverse chain rule to integrate that. I need to expand the brackets first. So if I do that, I'm going to get 0.4 times by itself, so that'll give me 0.16. Then I'll have two lots of 0.4 times by 0.2 cos 2 theta. So that will be two lots of 0.08 cos 2 theta. So that'll actually be 0.16 cos 2 theta. And then the last term is going to be 0.2 cos theta times by 0.2 cos theta, which will be 0.04 cos squared 2 theta, and then d theta. Now what I'm going to do now is to take out 0.04 as a factor. So then the constant on the other side now is going to be half times by 0.04. That is 0.02, or 1 over 50. I'll just write it as 1 over 50. So I've got 1 over 50, and then 0 and 2 pi. So I don't need to take out the factor. I just prefer if I take the factors out. So I'll have 4 plus 4 cos 2 theta plus cos squared 2 theta. Now the 4 we can integrate, the 4 cos 2 theta we can integrate using the reverse chain rule because the inside is linear 2 theta. However, we can't integrate the cos squared 2 theta, so we need to use a trig identity to change that. So the trig identity we're going to use is cos 2 theta is equal to 2 cos squared theta. So what I'll do is rearrange this to make a 2 theta here, and then make that cos squared the subject. So if I just double up the angles, so change that 2 theta to 4 theta, which means that I can change this theta here to 2 theta. So cos squared 2 theta minus 1. Then I can add 1 to both sides, then divide both sides by 2, and then I'll get cos squared 2 theta is equal to half cos 4 theta plus a half. So that's going to go in here, and then that's going to give me something which I can integrate. So let's write that down. So 1 over 50, 0 to 2 pi, 4 plus 4 cos 2 theta, and then plus a half cos 4 theta plus a half d theta. So we can tidy this up a bit. I can take the half out as a factor. But before I do that, I'll put the 4 and the half together. So let's take out the half at the end, because I'm just going to add it to the 4 that's there. So I've got 4.5, which is 9 over 2. And then taking that half to the other side, I'll do that here as well. So 1 over 50 will become 1 over 100. The 9 over 2 will just become 9. The 4 will become 8. And the half goes. Just makes things a little bit easier to deal with. So you've got cos 4 theta d theta. So I'm now ready to integrate. So 1 over 100. The 9 will become 9 theta. The 8 cos 2 theta, well, if we use the reverse chain rule for this, cos will become sine integrated, then I divide by this differentiated, so I need to divide this by 2. So I will end up with 4 sine 2 theta. And then here, same thing again, cos will become sine, and then I divide by this differentiated, so I'm going to divide by 4. So that will be plus a quarter sine 4 theta. And my limits were 0 and 2 pi. So I'm now ready to put the limits in. So 1 over 100. And if I put the 2 pi in, so I'm going to have 9 times by 2 pi plus 4 sine 2 times by 2 pi, and then plus a quarter sine 4 times by 2 pi. And then I'm going to subtract, I'm going to need another set of brackets here. I'm going to subtract 9 times by 0 plus 4 times by basically sine 0, isn't it? 2 times by 0 plus a quarter sine 4 times by 0. And I think there was another bracket here right at the end. So 1 over 100. Let's see what we get from the first bracket. So that's 18 pi. And then the second bracket here, this is all 0. So that leaves me with basically the 100th of 18 pi. And that's 9 over 50 pi. Okay, so we're almost done. So what we've got now is the area of this part, which is 9 over 50 pi. Let's just write that in. 9 over 50 pi. We worked out the area of this part right at the beginning, so that's 0.72. So I'll put that in. So what we've got left to do now is just subtract one from the other. Let's put that here. I don't really want to rub anything out. Keep the work in here. So we're now going to do 0.72 minus 9 over 50 pi. And on my calculator, I get 0.154513 and so on. The question does say that we need to give our answer meters squared to 3 significant figures. So 3 significant figures here is going to be 0.155. So final answer 0.1, not 1 point something, 0.155 meters squared, and that's the 3 significant figures that they wanted. So that will be our final answer here for part B.